Okay, hi everyone. So in this lecture, we'll learn about bacterial growth and nutrition. So in this lecture, we will learn about basic principles of microbial growth, cell division and growth measurements, growth phases in a bacterial culture, factors affecting bacterial growth, and various laboratory culture medias. Okay, the general definition of growth is an increase in cellular constituent that may result in an increase in cell size, an increase in cell number, or both. But on the other hand, the definition for bacterial growth is defined not in terms of cell size, but increase in cell number or in population. It is because the bacteria, they grow only to divide, not grow in size. So which means they won't get fatter or thinner. And then usually the bacterial growth will observe in a population because it's very hard to observe a single unit. Okay, bacterial cell division. So the cell division in unicellular organisms, which including bacteria, occurs via binary fission. So binary fission is an asexual cell reproduction, which means it doesn't involving male and female cells. And no cell division cycle also happen in the bacteria. So usually cell will grow twice its size and then divide into two daughter cells. Okay, during the binary fission, the cell elongates and DNA is replicated. And after that, the cell wall and plasma membrane begin to divide. So usually a cross wall will be formed. And the early formation of the cross wall or like partially formed cross wall we call as a septum. S-E-P-T-U-M. And I'm really sorry for my poor writing. And after that, the cross wall fully formed around and DNA will be separated into two different portions. Once the DNA is fully separated and the cell is fully matured, the cell gets separated into two individual cells. Okay, bacterial generation time. So bacterial generation time is the time required for a bacterial cells to grow and divide. So which, in other words, a time required for one bacterium cells to become two bacterial cells. And it is also known as the time required for a population of bacterial cells to double themselves during the log stage of the growth. So we will look into more details what is log stage in the following slides. And it is also expressed in the units of minutes and it varies between bacteria. So usually if it's a fast growing bacteria, the generation time usually 20 minutes. If it's a slow growing, usually up to 20 hours. So let's say you have a bacteria with a generation time of 30 minutes. So which means after 30 minutes, one bacterium cells will become two. And then after 60 minutes, this two bacteria will become four bacteria. And in 90 minutes, so they will become 8 cells and 120 is so on. Okay, bacterial growth phases. So when a population of bacteria introduced into a closed liquid medium, or we also known as a batch culture, so they display four major phases of growth, which are lag phase, log or exponential growth phase, stationary phase, decline or death phase. And these phases will make into a standard bacterial curve. Okay, this is how a bacterial growth phases will look like, or also known as a growth curve. So your y-axis is usually a logarithm of viable cells, so which means number of living cells, and your x-axis is your hours. So the curve usually starts with a lag phase, followed by exponential growth phase, or also known as a log phase, followed by stationary phase, and the last one is your death phase. Okay, first is the lag phase. So lag phase is also known as a phase of adaptation to the new medium. So what happens here is that the cells has been transferred to the fresh medium. So usually we take time to adapt to the fresh medium. So at this phase, the cells are metabolically active to synthesis enzyme and other metabolites to prepare for multiplying. And the cells are growing in size and in preparation for cell division. So the length of this lag phase is dependent on a few factors. The first is the bacterial species. Let's say your bacteria is a fast grower, usually will have a shorter lag phase. If it's a slow grower, will have a longer lag phase. And also depend on the culture media. If you provide a rich media, the bacteria will grow faster and then will have a shorter lag phase. But then if you provide a less rich media, you will have a longer lag phase. And also depends on the damages you are exposed to the bacteria. Let's say your bacteria are exposed to heat, radiation, or toxic chemical, it may take longer for the lag phase. So which means the bacteria will take longer time to adapt to the medium. Okay, the second one is the log phase. So the log phase will begin once the organism have adapted to the fresh medium or new medium and synthesize the necessary chemicals for the population growth. And usually the reproduction at log phase rapidly occur and at an exponential or logarithmic rate. And log phase lasts for a limited time and depend on availability of a fresh nutrients. Let's say you have like a more fresh nutrients or like more volume of nutrients, so the log phase will have like a long duration. If you have like a limited nutrient or less nutrient, the log phase will have a shorter time. And usually for research purposes, the log phase bacteria will be used, and then there's a few reasons for it. And during the log phase, the bacteria will show their visible characteristic, which is including shape, arrangement, and color. And then during the log phase, the bacteria are also more sensitive to adverse conditions, for instance exposure to antibiotic, because at log phase the bacteria are most active metabolically. And this is also optimal stage to use bacteria for gram staining, measure generation time, and other laboratory and industrial purposes. Okay, third, the stationary phase. So when cell division decreases to the point that new cells are produced at the same rate as the old cells die, and the number of leaf cells stay constant. So just remember, the number of cell death equivalent to number of new cells is the stationary phase. And this is occurring due to the depleted nutrients and increase of waste, and represented by a horizontal line in the growth curve. And the cells are more resistant to environmental changes during stationary phase, such as heat, drying, and radiation. And apart from that, secondary metabolites also will be produced during the stationary phase, which is including antibiotics and some enzymes. And furthermore, endospore also will be produced by some bacteria during the stationary phase. Okay, the last one is the decline phase or a death phase. So as the condition in the medium become less supportive for the cell division or the bacterial growth, so many cells will lose their ability to divide and thus the cells die. So which means the cell death is more than cell growth or the production of new cells. And in this decline or death phase, the number of leaf cells decreases at a logarithmic rate. And the duration of this phase is variable and mainly depend on species and genetic characteristic of a organism. So for instance, a few cells or so-called persisters are characterized by a slow metabolic rate. So persister cells are medically important because they are associated with certain chronic infections, which is including tuberculosis, which is not respond very well to the antibiotic treatment. Okay, this is a summary of the bacterial growth phases. So just remember, your y-axis is the bacterial number, and then your x-axis is the time. So when you first transfer a bacteria into a fresh media, it will start with the lag phase. So where the bacteria is still adapting to the fresh media. And as I see, usually the question they will ask is, where am I? Okay, and then followed by exponential phase, where the bacteria are fully adapted and then they're growing very rapidly. Okay, if you look at here, they enjoy growing. Okay, followed by the stationary phase, where the cells are too crowded. They're too crowded and then they're congested, and also depletion in the nutrient, where the growing condition become unsuitable for the bacteria. And the last phase is the death phase, so where the bacteria are dying due to lack of nutrient. So the thing that I will say is like, oh dear, I am dying. Okay, let's look how we can calculate the number of cells. So cell enumeration formula using generation time. Okay, the relationship between the number of bacteria in a population at a given time is NT. The original number of the bacteria cell in a population we call as a N0, and then the number of division those bacteria have undergone during a given time is we call as a N. Okay, so the formula can be expressed as NT equal to N0 times 2 to the power of n. Okay, this is an example on E. coli. okay, or Escherichia coli. So under optimal conditions as a generation time of 20 minutes. So if one started with 10 E. coli cells, so which means your N naught equivalent to 10, and allow them to grow for 12 hours. So which means the N equal to 36. So how we get this value 36? So 12 hours times with 60 minutes per hour, so you will get 720 minutes. And 720 minutes divided by the 20 minutes of generation time, so you will get N equivalent to 36. Then plugging the numbers into the formula, the total number of bacteria after 12 hours, NT will be obtained. So NT, so 10, which is your N0, times 2 to the power of N, which is 36 in this case, so you will get this much cell. So to be honestly speaking, I have no idea how to read this number, so I just leave it as it is now. Okay, that's all for this lecture, and then please post your question in the e-learn.